Guys, in previous classes, what we discussed? We
We
discussed
discussed
about
about
the
Kubernetes architecture.
we discussed about the Kubernetes and Kubernetes architecture, right? So you already know the Kubernetes architecture, right? This is the Kubernetes diagram, Kubernetes architecture. So Kubernetes architecture. So this is the control plane is nothing but a master node. So master node contains the API server, scheduler, control manager, and etcd. So what is that, guys? A control plane array, a master node. So master node contains, guys, everyone can speak out. So API server, a scheduler, control manager, and etcd. Scheduler, API server, scheduler, controller manager, and etcd. So what this is, I want to how you can connect with the master node. So you can connect with the master node through CLI or a UI. So how you can connect, guys? You can connect through the CLI or a UI. What is the CLI command, guys? So CLI command is kubectl. So CLI command is a kubectl. Guys, understood?
Yes, sir.
Yes, sir. So Kubernetes is very easy, guys. If you know the Docker, Kubernetes is a very easy. So for example, so this is your Kubernetes cluster. A cluster contains, what is a cluster, guys? Guys, what is a
Group,
cluster?
group, right?
Yes, group of
Node.
nodes. Group of nodes. Or node is nothing but a, guys, node is a nothing but a EC2
Instance.
instance. A node is nothing but a EC2 instance. So for example, so this is also a master node, and so these two are the worker nodes. These two are the worker nodes. Guys, listen carefully. Okay. So what this is? This is a control plane. So what is control plane? Control plane is nothing but a master node. So control plane is nothing but a master node. So this is worker node 1, and this is worker node 2. So worker node 1 and worker node 2. So master node contains what master node contains, guys? So this is one EC2 instance. So what this is, guys? This is a one EC2 instance, right, guys? EC2. So EC2 instance. So EC2 instance. So this is a one EC2 instance. This is one EC2 instance. So this is also EC2 instance. So this is also one EC2 instance, and this is also one EC2 instance. A node is nothing but a EC2 instance, guys. So what it contains? So what it contains in the a master node, guys? API server, etcd, scheduler, and control manager. So what it, guys? These all are the components in the control plane. So these components will handle these nodes, and will they handle these nodes and nodes and pods. I will tell you, guys. Pod is nothing but a container. For example, a container. So before, so you run a container in the EC2 instances. Who will handle? Who will maintain this one? No one will maintain this one. So who will maintain the Kubernetes control plane will maintain this, right? But how we can connect with this control plane? So we can connect with this control plane either two ways, guys. So one is a GUI, so the other one is CLI. So what is that, guys? GUI or a CLI. So how you can connect? So so CLI. So if you want to connect the CLI, right? Again we need a remote instance. So what you need? You need a remote instance. Through the remote instance, we can connect to the server. Then we can execute the commands like kubectl commands. Okay, kubectl command through the kubectl commands. So we can handle these and handle these pods or a containers. So this is a CLI mode. CLI. CLI is nothing but a commands. This is a UI or GUI. So what are the tools are there for the GUI? So there are the tools for RKE and OpenLens. So what are those, guys? RKE and the second one is OpenLens. So for example, guys, OpenLens, right? So I can open this is the OpenLens. Yeah. So through this open lens, we need to provide the here, right? So we need to how we can connect. We can connect with the through this configuration files. Okay. So you want to connect through the cluster node. You want to connect to this cluster node, either open lens, GUI mode, or a CLI mode. CLI means through the remote machine. So now you understood, guys. So whatever the instructions kubectl, if you, kubectl if run the command, right, it will API server take it and store it in the HCD and move to the scheduler. Scheduler will manage the control manager. So simple things, guys. Simple. So here a kubelet and the Kube-Proxy, kubelet, Kube-Proxy and the Docker runtime. See, these are the four components in working in the here. Kubelet, Kube-Proxy, and Docker runtime. So Docker runtime is nothing but a Docker service. What is that, guys? Docker service. So this Docker, if you have, if you, Docker service is running, then only the container running, right? Otherwise, it will not running. See, Kubelet is acting as a agent in between. So in between control node and worker node. So control node and worker node, right? That Kube-Proxy, so we'll check it where the space is available, where the resources available. Here worker node 1, so it doesn't have the resources. So the kubelet will check the worker node 2 and will deploy the containers in the worker node 2. So Kube-Proxy is nothing but a networking. So that is nothing but a networking concept. So we'll show you later, guys. We'll tell you later. Guys, now you understand the Kubernetes cluster architecture. Kubernetes architecture. Now you understand the Kubernetes architecture or not?
Yes, sir.
Guys, yes, right? So it's a simple, guys. It's a simple. So why we need Kubernetes, guys? So why we need Kubernetes?
It monitors without failing.
Yes.
It's some
So it
pod
it managing or maintaining the pods
Docker
or a
service.
containers. Okay. So before that, so Docker some also working as same Kubernetes, but so Docker some having some of the drawbacks. That's the reason Kubernetes is more popular. So Kubernetes is more popular, more popular. Guys, understood? Yeah. So this is the a diagram of the Kubernetes architecture. kubectl is the command mode in order to perform the operations on the master node. In order to perform the operations on the master node. So, so run the command on the kubectl. Okay. So execute a command by kubectl, execute a command by the kubectl. So if you run the command something like a kubectl apply something like a deployment.aml. So for example, so this is the one file. So for example, he created a one file, call it as a the file call it as a name, call it as a deployment.aml. So if you want to run this if you want to apply this aml file kubectl apply -f, so deployment.aml. So once you click this deployment.aml, so API server will talk. API server so will talk. Yeah, so execute the command by the kubectl that will talk to the API server, and API server will act as a mediator between the kubectl and the Kubernetes software. So this is the Kubernetes software and this is the kubectl. So it's a mediator between the Kubernetes kubectl command and the Kubernetes software. So this is the Kubernetes software. So whenever a request comes from the kubectl, so whenever a request comes from the kubectl, so that will be taken care by the API
It
server. So
like
that will
it
be,
schedule
yeah. So API server will talk to underlying the Kubernetes software. So whenever a request comes from the API server, and API server stores the information, the etcd. So this is the file, right? So this file will store it under etcd. etcd is the database file. Stores the data. So whenever you execute the command, right, it will directly talk to the API server. API server will talk to the software, Kubernetes software. Whenever a request comes from the kubectl, that will be taken care by the API server will talk to underlying Kubernetes software. So whenever a request comes from API server stores the information in the etcd. etcd is a data store in the Kubernetes, and it will act as a database to store to store the details of the Kubernetes cluster. Scheduler. Next, scheduler. A scheduler is going to check that what are the pending tasks are available. Then scheduler is going to assign the task to the controller manager. Scheduler will check, and if there are any unscheduled pods, so directly scheduler will talk to the control manager, and control manager is going to schedule them the before going to schedule. Scheduler will talk to the kubelet, right? This is the kubelet. So scheduler will talk to the kubelet. Kubelet is a worker node agent. It is going to check the health of the node, and kubelet will check the resources available in the node, and kubelet will make sure pods are running successfully and the containers are running successfully, right? Who will take care? Kubelet. Kubelet, it will check the health of the pods, and if you want to create a new pod, who will create? Kubelet will create. So successfully, so the pods are running successfully and containers are running successfully. Kubelet will create a containers on the worker node. Kubelet will create a containers. Kubelet will create a containers on the worker node using the pods with the help of Docker runtime. So Docker runtime is we are using to create the containers. Container is nothing but a runtime of our application. So container is nothing but a runtime of our application. Our application is deployed on the container only. Guys, now you understood. Now you understood the Kubernetes diagram, architecture,
yes, sir.
architecture. Yes, right? Yeah. Slowly it will understand, guys. No worries. Yeah, Kubernetes cluster setup. There are multiple ways to set up the Kubernetes cluster. I already told you, right? So provider managed Kubernetes cluster and self-managed Kubernetes cluster. Guys, so self-managed Kubernetes cluster and provider managed Kubernetes cluster. So what are the provider managed Kubernetes clusters, guys? So provider, cloud provider managed Kubernetes cluster.
Like AWS is this one.
Yes, yes, AWS. AWS created which service, guys, as a Kubernetes cluster? So which service they created, and kept it in the services, AWS services? EKS. I already told you, right, guys? EKS. So Elastic Container Services. Azure. AKS. Azure Kubernetes Service. Google. GKE.
EKS.
Google Kubernetes Engine. Oracle. OKE. Oracle Kubernetes Engine. IBM. IKE. IBM Kubernetes Engine. Kubernetes Engine. So that is nothing but a provider managed Kubernetes cluster. Provider manager Kubernetes cluster. We don't want to manage anything. We just deploy our application. So once we took the service, so who will manage everything? So AWS will manage, cloud provider will manage everything. We just deploy our application. We just deploy our application. There are multiple ways to set up the Kubernetes cluster: self-managed Kubernetes cluster, provider managed Kubernetes cluster. So self-managed Kubernetes cluster means how to set up the cluster for Kubernetes to run our applications. So lot of commands to install for our self-managed clusters means we have to set up the cluster of Kubernetes to run our applications. To create a self-managed cluster, we have two options. To create a self-managed Kubernetes clusters, so we have two options. One is Minikube. So Minikube is nothing but a single node Kubernetes cluster. So what is that, guys? A Minikube, it is nothing but a single node Kubernetes cluster. It will be only one node, and the control plane and the worker node both are installed in the one EC2 instance called as a Minikube. It is used for the development purpose only or R&D purpose. Guys, understood? Minikube. So Minikube is a single node Kubernetes cluster. So self-managed cluster means we have to set up the cluster of Kubernetes to run our applications. So to create a self-managed cluster, we have two options. One is a Minikube single node Kubernetes cluster or the KubeADM multi-node Kubernetes cluster. What is that, guys? So KubeADM multi-node Kubernetes cluster. So KubeADM is a tool designed to bootstrap a full scale of Kubernetes cluster. It takes care of the all heavy lifted related cluster provisioning and automates the process completely. Okay, it's a KubeADM multi-node Kubernetes cluster. So now you understood. So this is a multi-node Kubernetes cluster, and the Minikube is nothing but a so that control plane and the worker node. So this is the control plane and this is the worker node. So
Only
this is
single
the
node, sir.
single node, a single node. Single node. So we installed the Kubernetes cluster control plane and the master node. Guys, understood?
Okay, sir.
So
Sir, we prefer self-managed or provider managed.
for the development purpose, for the practicing purpose. So for the practice purpose, we can use for the development purpose. So development team, right? Development team are not using that much capability of the resources, right? So we can use the single that Minikube for the development purpose or a R&D purpose or a practicing purpose. Okay.
This provider
KubeADM.
managed use no, sir. Yeah, self-managed.
So which one?
Above we have
So we are I'm talking about the only
companies.
self-managed.
In companies we use provider managed or self-managed.
Both. So earlier we used the provider self-managed. So now we are moving from self-managed to provider managed.
Okay.
Okay. So it varies from companies to company. Avinash. Okay.
Yes, sir.
Yeah. Setup Kubernetes cluster setup. Kubernetes cluster we can set up in multiple ways. Kubernetes cluster we can set up in multiple ways: self-managed Kubernetes cluster and managed Kubernetes cluster. So self-managed Kubernetes cluster is KubeADM multi-node cluster, and Minikube is a single node cluster. So managed Kubernetes cluster, AWS EKS, Azure AKS, GCP GKE, IBM IKE, or Oracle OKE. These all are the provider managed. So Kubernetes cluster setup, provider managed cluster means we will use the Kubernetes cluster which is configured by someone. So provider managed means, so we will use the Kubernetes cluster which is configured by the someone. So Elastic Kubernetes Service, Azure Kubernetes Service, Google Kubernetes Engine, IBM Kubernetes Engine, or OK Oracle Kubernetes Engine. So these all are the provider manager cluster means we will use the Kubernetes cluster which is configured by the someone. Right? So EKS by AWS. AWS provides the EKS, Elastic Kubernetes Service. It is a provider managed Kubernetes service. Provider managed Kubernetes service. It is not a self-managed Kubernetes service. It's not a self-managed Kubernetes service. It's a provider managed Kubernetes service. Is understood? Yeah, Kubernetes cluster setup. So Kubernetes cluster setup, create one security group with a protocol all traffic port range 0 to 65535. Then create a 3 Ubuntu servers using above created security group and one master node. The master node is nothing but a T2 medium instance, guys. So what is that? A T2 medium. T2 medium means at least 4 GB of a RAM and 2 CPU, guys. It is a 4 GB of a RAM and 2 CPU. So then only we can set up the Kubernetes cluster. So I already informed to that guy and it will create it. So master node T2 medium instance. So worker node is a small is enough, guys. T2 micro instance is enough. So Kubernetes Minikube is one node Kubernetes cluster where the master process and worker process both are run on one node. According to the official documentation of a Minikube is a local Kubernetes focusing on the making it easy to learn and develop for the Kubernetes. A prerequisite to use a Minikube is a Docker container on a virtual machine and environment. Minikube provides you a way to easily deploy application on the Kubernetes for learning and developing purpose, even if you don't have enough resources like memory, CPU, etc. Yeah, how you can set up the Minikube? These are the documents, guys. So what is a Minikube? Minikube is a quickly set up a local Kubernetes cluster on Mac OS or Linux or Windows. We proudly focus on helping the application developers and the new Kubernetes users. Supports the latest Kubernetes release, cross-platform, and deploy a VM, a container or a bare metal, multiple container runtimes, direct API endpoint, blazing for the fast image, and the advanced features such as load balancer, so file system mounting, and feature gateways, and the network policy additions for easily install the Kubernetes applications, supports the common CI environments. So this is the architecture of the cluster. So we already see, right? This is the master node. So master node having the API server on Kubelet kube controller on kube scheduler and kube API server. So that etcd proxy and etcd kubelet will talk to the other underlying worker nodes. Okay. So self-managed setup, self-managed Kubernetes self-managed setup. Take three Ubuntu's. One is the master node. The two is the worker nodes. Install Docker and Kubernetes in both master node and worker nodes. Docker must and should install both worker node and master node. So install Kubernetes and install kubeadm and kubectl in the master node. Yeah, master node, worker node setup. So we can use the commands. I will give you guys, no worries. This is the self-managed Kubernetes cluster. Yeah, this is the Kubernetes cluster. But we are using the EKS, guys. So add a slave. So here it is recommended to run the commands in the master node. So the commands and everything. Launch a new EC2 VM using the running the these commands, guys. These command to install the Kubernetes, right? So Kubernetes core components, container, pod, namespace, service, and deployments. Kubernetes, right? Kubernetes core components. So we are using Docker to create a container on our application. Docker will be used as a runtime engine in the Kubernetes cluster. Kubernetes is used to manage our Docker containers. Kubernetes will manage our container, but not directly. It will use pod to manage the containers. Pod is the smallest building block which we can deploy in Kubernetes cluster. Containers will be wrapped under the one unit called pod. Containers will be wrapped under one unit called as a pod. Guys, now you understood? So Kubernetes will manage our containers, but not directly. It will use the pod to manage the containers. Guys, understood? So we are using Docker to create the containers for our application. Docker will be used as a runtime in the Kubernetes cluster. Kubernetes is used to manage our Docker containers. Kubernetes will manage our containers, but not directly. It will use pod to manage the container. It will use pod to manage the container. Pod is the smallest building block which we can deploy in the Kubernetes cluster. So what is the guys? So pod is a smallest pod is a smallest building block. Small is a pod is a smallest building block which we can deploy in Kubernetes cluster. So container will be wrapped under one unit called as a POA. Okay. So next, the POD is the smallest building block which we can deploy in Kubernetes cluster. So container will be wrapped under the unit of called of POD. So in Docker, to get the clarity to get so in Docker, container is the smallest part, so we can deploy, whereas a Kubernetes pod is the smallest part of smallest smallest part we can
We can
deploy.
deploy.
So now to get the clarity of the pods, we need to understand the namespace first in the Kubernetes. So right guys, so namespace I will show you, no worries. So how you can create the yeah guys. Yeah, guys, what is a pod? Pod is a smallest building block what we can execute inside the Kubernetes cluster. Pod will execute in a node. Okay, guys. Pod will be executed in the node. Node is nothing but EC2 instance. So one node can execute multiple pods. Yeah. So one node can execute multiple pods. So pods can have one container, more than one container. So yeah, as usual, guys. So pod can have one container or more than one containers. A pod have, so so in one pod contains one container or multiple containers, so we can allow. Pod represents a running process. So container inside the pod will share the unique network IP, storage and other specification. So to run our application, to run our Docker image, we need to create a pod, then create a executed that pod. So if we have a pod, then we can send, so we can send a request to the scheduler that pod execution. Pod execution. So how to run our application in Kubernetes? To run our application Docker image, we need to create a pod. Then Kubernetes will extract that pod and in a single node. Now we have a pod. We can send the requests to the Kubernetes to schedule that pod execution. So we can create a pod in two ways. So we can create the pod in two ways: interactive and declarative. So pod in two ways. So we can create pod in two ways. Interactive modes. So interactive approach means using commands. So we can create a pod. Declarative means so approach means we can use the manifest file. Write YAML. We can create the pod. So what is a pod? A pod file contains the API version, kind, metadata, spec. These four are available in the that file. API version, kind, metadata, spec. So meaning of the API kind metadata. API version represent a version of our API like V1, V2, V3. Kind represents what is the purpose of the manifest file, and metadata represents the data about the data about the tables, and spec represents the specifications. So what you want to use for this manifest. Is understood? So API version represents the version of our API like V1, V2, V3. Kind represents what is the purpose of manifest file. Metadata represents data about the data, and spec represents the specification of a manifest file. So guys, I will show you how to create a pod lifecycle, and what is Kubernetes service. So I will tell you cluster IP. So we need to so manually pod created. What is the replication controller? Scale down, manifest file creation, replication, replica set, difference between equality, replication controller. What is the ELK architecture? This is the ELK architecture. What is the daemon set? Pod creation, deployment status is all type of status create, recreate, rolling update. Yeah, so we can install the Kubernetes by using the EKS, guys. I will show you how to install the. So one thing you guys can do, one thing in the yeah, guys. Here I showed you. Yeah, I make IT. Yeah, guys, in that bench I created the AC. So Kubernetes installation part for DevOps AWS. So EKS. Okay. EKS. Okay. How you can set up so this. So yeah, how you can create the EKS and how you can create the manuals also. I show to you guys. You guys can watch these recordings. You will understand. Okay. So this is the two recordings. You guys can watch it. The Kubernetes, how to create the manually and how to create the Kubernetes while using the Kubernetes cluster. Okay, guys.
Okay, sir.
Yeah. So we'll show you guys. We'll show you tomorrow how to install the Kubernetes on EKS. Okay.
40 to 43.
Hmm?
40 to 43 class.
Class 42, 43. 42, 43.
Okay.
Okay. And you guys can watch this. So watch this one also. Yeah, here also. Here also I show you, right? This is John. Or here also I showed you guys. Here also I showed you. Yeah, I will ping you in the chat, that WhatsApp chat, guys. The how to install the cluster via manually. So I have a document, guys. You guys can go through the document. 1 second. Alright, no worries. I will ping you. I will paste to the. I will upload here how to deploy the, how to create the EKS cluster through the EKS cluster, and how to install the Kubernetes through the manually. I will ping you here, guys. I will upload the recording here. Sorry, I will upload the document here. Okay. Okay, so we'll continue from tomorrow, guys. So tomorrow I will show you, and I will ping you in the WhatsApp chat the two, guys, how you can set up the EKS, how you can set up the manual things. Okay.
Okay, sir.
Yep. Thank you, guys.